We know that y equals mx plus b is the equation of a straight line. And we're going to work with that for the next little while. Remember that m is the slope and b is the y-intercept, which is what we're going to fill into these first few blanks. So we have to know the slope and the y-intercept. Where m is the slope and b is the y-intercept. So as long as we know those two things, then we can always write the equation of a line. Remember, x and y are just the variables, so that's what we're relating to each other. X and y, x could be distance, y could be time, or anything that can be related to each other. So those are the variables, they change. But also, as far as graphing goes, x and y are ordered pairs that we can graph on a Cartesian plane. So let's take a look at some examples. State the slope and y-intercept of the following. So again, slope is going to be m, y-intercept is going to be b, and we're going to be putting it in the form y equals mx plus b. Actually, we're not putting it into that form, we're pulling it out of that form. So let's use a little highlighting color magic here. So I'm going to highlight the slope in yellow. It always comes right in front of the x, and so I recognize it's the slope because of where it is. So in this first example, the slope is 2. And we always recognize the y-intercept by where it is as well. It's not with the x at all. If m is with the x, then the y-intercept, I'll use green for that, b, is always plus or minus some number. And if it's in the proper, correct form, then it always just comes at the end. So the y-intercept is 5. So we have a slope of 1/4 and a y-intercept of -3 in the second one. And maybe it's worthwhile just to quickly remind you of what these things mean. I'm just going to do a rough sketch, but if we have a y-intercept, if I'm going to graph things, it's always, we need to have a starting point. Okay, let me go back to number 1 for a second. Slope was 2, y-intercept is 5. So what actual point do we know on this graph? Well, we only know one point. We know the b. We know that it crosses the y-axis at 5. The slope tells us, it's sort of like directions. It tells us where to go, but we have to have the starting point. So for this one, my starting point, whoops, I always forget to change it back. My starting point is at 5 on the y-axis. So this will just be a little sketch. Let's imagine that this is 5 on the y-axis. So let's pretend that that's where our scale is. So I know that on this up and down vertical y-axis, I've got this point where the graph is going to go through it. Now remember what the slope is. Slope, like I said, is direction. Slope is rise over run. And so we can always think of slope as a fraction. This first one isn't given as a fraction, so what do? Well, we think of it like a fraction, 2/1. So that means that from any point, for example, the y-intercept, if we go up 2 units and 1 unit to the right, that's our run, then we'll get another point. So up to 7 and over 1 will give me another point. And then from there I can go up by 2 and over 1 again. So again, the slope is just giving me directions. And then I can just connect everything with a straight line, and I can really draw my line quickly like that. And that's really all there is to it. So let's try it again for example 2. We always start with the y-intercept. What's the y-intercept in this case? -3. Let's say that's down here. Negative means below the x-axis, right? Still on the y-axis though. So there's -3. Now my slope is 1/4. Rise over run. So from this point, it'll go up 1 and then 4 to the right. So again, I'm just estimating where that would be. But you can see it's going to go side to side 4 times as much as it's going to go up. Go up 1 more and 4 more to the right. And again, after I've got a couple or few points, then I can connect the dots, and that's what that line would look like. So with this slope and y-intercept, I can graph things really quickly. So let's get back to where we were doing before, answering the question, slope, -2/5, y-intercept 1. Remember, when we have fractions, I always encourage you to put negative sign in the numerator, if there is a negative sign. That way we can think of this as a negative rise over a positive run. So again, that'll just help us when we're graphing things. Again, I'll just start at the y-intercept of 1. So I always start with the y-intercept. Okay, there we are at 1. But now my slope says I go down 2 from there, and then 5 units to the right. So down 2 from 1 on the y-axis, go down 2, I go down to -1, go over 5 to the right. I'd have a point somewhere over here. And my graph would look something like that. Remember, negative slopes, that negative slope means it goes down from left to right. And we've seen that before. The last one throws a bit of a curveball at us. And the thing is, it's not in this form y equals mx plus b, right? Mx plus b implies that the x comes right after the equal sign, or very soon after the equal sign. If I was to rearrange this into the standard form, I'd move the -2x, that whole term, first, and then I'd have +3. So remember, the slope always, I don't have to rearrange it. I mean, if I recognize what's what, then I can leave it in that form and work with it like that. But I think it's better to put it in the proper form. So -2 is the slope, and 3 is the y-intercept. Okay, let's do a quick sketch because it is so quick and easy. Y-intercept 3, slope -2, which is -2 over 1, go down 2 over 1. Go down 2 from there, over 1. And do as many points as I feel like I need so that I can draw a nice graph. There's 4 points. That certainly should be enough. And again, notice how this negative slope goes downward from left to right. So we can use slope and y-intercept to graph a line. That's exactly what I've just been doing. Here's the steps. Plot the y-intercept first because we need that point as a starting point. Then count the rise and the run to get the next point, then get another point, then join all the points, and you're good to go. So here's a couple more examples just to drive it home. Y equals 2x plus 1. What's the starting point? Well, the starting point is the y-intercept plus 1. Now this one I've got a nice grid for, so I can be a bit more accurate. So there's 1. Where do I go from there? Well, from there, I use my slope as directions, 2. But think of it as 2 over 1. Think of slope as a fraction. From there, go up 2 and 1 to the right. Okay? Then go up 2 and 1 to the right from there. And do that over and over, however many times you need to, until you feel like you've got enough points to draw your graph. But it's quick. Here's another one. Where's my starting point? Well, my starting point, again, is 3, my y-intercept. And my slope is -1, put the negative on the top, over 4. So from 3, I go down 1, 4 to the right. And then from there, down 1, 4 to the right. Now these points are a bit more spread out, so I don't need quite as many in order to draw a decent graph. Notice how I'm filling up the whole grid, though. I always think you should do that. Don't make stubby little graphs. They're not very pleasing to look at, and they're not very useful either. So what you should do is always fill up the whole graph like I've done. So that's how we graph something with using y equals mx plus b.